What if I told you that a man with almost no formal education unlocked secrets of the universe that even the greatest mathematicians struggle to comprehend? A man who claimed that a divine entity whispered complex equations into his dreams, equations that would baffle experts for decades to come. This is the story of Srinivasa Ramanujan, the mathematical genius educated by God. Let's first look at a mathematical question. If we add all positive integers infinitely, summing 1 add 2 add 3 all the way to infinity, what is the result? Some viewers might say, although I can't immediately give an answer, common sense suggests that the result should be an extremely large number. However, in mathematics, once infinity is involved, everything must be reconsidered. Just like how physics enters the realm of quantum mechanics, the final result of summing 1 add 2 add 3 all the way to infinity is surprisingly negative 1/12. Ramanujan was born on December 22, 1887, in Erode, India, a small impoverished town far from the state capital of Madras, now Chennai. Despite belonging to the highest caste in India's caste system, his family was extremely poor. They survived on his father's modest salary of 20 rupees per month. Unlike some child prodigies who show talent at age 3 or 4, Ramanujan's mathematical gift wasn't recognized until 1898, when he was 10 years old. That year, he attended school and encountered formal mathematics for the first time. At the same time, 2 college students rented rooms in his home, occasionally teaching him mathematics. By the time Ramanujan was 11, these 2 students admitted they could no longer teach him anything, even though they were studying at a prestigious university. At 12, Ramanujan borrowed a book called Plane Trigonometry by S.A.L. Loney. Astonishingly, he self-studied the entire book in a short time, solved every problem, and even independently derived Euler's formula. During high school, he found a book in the library, a synopsis of elementary results in pure and applied mathematics by George Shoebridge Carr. This book contained over 5,000 formulas from algebra, calculus, trigonometry, and analytic geometry, but without any proofs. Yet Ramanujan was fascinated. He devoted himself to proving all of them on his own. Ramanujan claimed that the Hindu goddess, Namagiri, would appear in his dreams and present him with intricate mathematical formulas. These equations, often far ahead of their time, would later be proven correct, stunning the greatest mathematical minds of Cambridge, where he eventually studied. But here's the real mystery. Why is Ramanujan considered a genius? Because, despite lacking formal education, he exhibited an extraordinary talent for mathematics. He could write incredibly complex mathematical formulas relying solely on intuition. Since he did not provide the proofs, no one at the time could fully understand them. Many years later, mathematicians finally deciphered some of these formulas, leading to major mathematical breakthroughs. For example, in 1973, Belgian mathematician Pierre Deligne proved a conjecture Ramanujan proposed in 1916, earning him the Fields Medal in 1978, the highest honor in mathematics. Many of his discoveries were so advanced that they only found application in the modern age, over 100 years later. His work on partition functions, Mach theta functions, and prime numbers is now used in fields such as black hole physics, string theory, and cryptography. How could a man, working alone in the early 1900s, foresee equations that are now essential for cutting-edge technology? When modern scientists studied his mysterious formulas, they found that several of his theorems applied to diverse fields, including particle physics, statistical mechanics, computer science, cryptography, and space technology. Ramanujan's mentor, friend, and biggest supporter was G.H. Hardy, a legendary British mathematician. Hardy once said that his greatest contribution to mathematics was discovering Ramanujan. He even remarked, "We study mathematics, but Ramanujan discovered and created mathematics." Interestingly, Ramanujan frequently told Hardy that his mathematical intuition came from God, something that deeply shook Hardy, who was an atheist. In 1919, the last year of Ramanujan's life, he wrote his final formula. It wasn't until 2012 that someone finally deciphered it. And it turned out that this function could describe the behavior of black holes. Just think about it. When Ramanujan first proposed this function, humans didn't even know black holes existed. Back at Ramanujan's India school, his mathematical excellence earned him a scholarship, but he was too focused on math. He neglected other subjects like English, and eventually lost his scholarship. He was later forced to drop out of school due to failing non-math subjects. Despite being impoverished, Ramanujan never gave up on mathematics. In 1909, he got married. As per tradition, he needed to find a job to support his family. He approached Euler, one of the founders of the Indian Mathematical Society, seeking employment. Recognizing Ramanujan's talent, Euler recommended him to Rao, another founder. Rao saw Ramanujan's potential and arranged to give him a stipend for a while, hoping to secure a research grant for him. Rao's application for a research grant was unsuccessful. Proud and unwilling to be a burden, Ramanujan stopped accepting financial aid. Without money for paper, he worked out equations on a slate and erased them with his elbow. Over time, his elbows became darkened and calloused from constant friction. Later on, Ramanujan eventually found a job at the Madras Port Trust, earning 25 rupees per month. Though the salary was low, it was enough to survive. He published papers in the Journal of the Indian Mathematical Society, gradually gaining recognition. Encouraged by friends, he decided to contact British mathematicians for help. In 1913, he sent identical letters to several top mathematicians at the University of Cambridge. One winter morning, Hardy later became his mentor. A great mathematician at the University of Cambridge received an unexpected letter from India. The envelope bore an Indian stamp with the date January 16, 1913. Though he had no acquaintances in India, he opened the letter, 10 pages filled with mathematical formulas. At first, Hardy dismissed it, as he often received letters from amateurs claiming to have discovered new mathematical truths. But something about this letter was different. That evening, Hardy and his colleague Littlewood examined the formulas for 3 hours. They didn't fully understand them, but one thing was clear. The person who wrote this letter was an undiscovered mathematical genius. Hardy invited Ramanujan to Cambridge, secured him a generous scholarship, and helped him formalize his mathematical knowledge. Over the next 5 years, Ramanujan published 21 papers in prestigious British, French, and German journals. His greatest achievement with Hardy was solving the partition function problem. Their formula for partition function number theory, the number of ways to partition an integer, was groundbreaking. In 1918, Ramanujan became a Fellow of the Royal Society, the highest honor in British mathematics, and the youngest ever at the time. Ramanujan's health declined. He contracted tuberculosis and spent his final years in a sanatorium. One of the most fascinating stories about Srinivasa Ramanujan is the famous taxi number 1729 incident, which showcases his extraordinary mathematical intuition. The taxicab incident? In 1919, Ramanujan was seriously ill and staying in a nursing home in London. Hardy came to visit him. Trying to make conversation, Hardy said, "I came in a taxi with the rather dull number 1729. It seems like an uninteresting number to me." Ramanujan, lying in bed, immediately perked up and replied, "No, Hardy. 1729 is a very interesting number. It is the smallest number expressible as the sum of two cubes in two different ways." Mathematically, what he meant was 1729 equals 1 cubed plus 12 cubed, and also equals 9 cubed plus 10 cubed. Hardy was stunned. For most mathematicians, recognizing such a unique property of a number would take hours of calculation. But for Ramanujan, it was instantaneous. This moment became legendary and led to the term taxicab numbers, which are numbers that can be expressed as sums of cubes in multiple ways. In 1919, he returned to India, but passed away in 1920 at age 33. His last notebook, known as the Lost Notebook, was missing for over 50 years before being rediscovered in 1976. It contained hundreds of unpublished formulas, some of which are still being studied today. Modern scientists found that his formulas had applications in cutting-edge fields, including black hole physics. Ramanujan always claimed his insights came from divine visions and God. Perhaps only such an explanation can account for his extraordinary mathematical abilities. Some researchers believe Ramanujan had an intuitive connection to the mathematical fabric of the universe. Others speculate something more, otherworldly. Could it be that Ramanujan was somehow accessing knowledge from a future civilization? Was he a genius born before his time, or was he a conduit for something beyond human comprehension? The mystery of Srinivasa Ramanujan remains unsolved. But one thing is certain: his legacy continues to shape the world in ways we are only beginning to understand. His story was later adapted into the 2015 film, The Man Who Knew Infinity. What do you think?
Subscribe and hit the notification bell so you don't miss what's coming next. Share it, because some stories are meant to be discovered together. And stay curious. I'll see you in the next chapter.